Hey guys, so I just come back from doing some internet research, and let me try to explain to you what this term mean. Okay, so it means that in common language, it means that okay, if you recall the binomial theorem, binomial theorem, say that what does it say? It say that u plus v to the power of n equal to n to k of summation k equals 0 to n into k, and choose k of u to the power of k times v to the power negative k. Okay, so now if we have d minus a to the power n, it means that it means the summation of k equals 0 to n of n choose k d to the power of k times negative a, be careful, negative a, okay, to the power of n. Okay, so yeah, with that being said, let's do one example. Okay, so or in other word, let me actually write in common language. It's not fully common language yet. N k dk. Oh, I'm not gonna write big D anymore. Not that big D. Big D has a lot of meaning. In this case, it means derivative operator. I mean, I'm pretty sure y'all know that that's out of meaning of big D. Now I'm gonna write case like this: d y over dxk. Okay, a. Okay, assume that y is a function of x. Okay. Okay, now let's do some example. Okay, let's say you want to write d minus a square. What does it equal to? It equal to summation k equals 0 and in this case n is 2. Okay, so 2k d k y dxk a. Oh, sorry, this is not n minus k. Sorry. Okay, now, okay, so it will equal to what? It will equal to k equals 0. This is k equals 0. Okay. D 0 times negative a. Oh, we forgot. In this case, n is 0. So sorry, guys. In this case, n right here is 2, because here we're replacing n with 2. Okay. So everything with n will go to 2. So 2 minus 0, okay, plus, okay, k equal 1. Minus 1. Okay. And then plus d. Wait, k equal, oh, sorry, k equal 2. E to y over dxy. A 2 minus 2. Okay, so what is 2 times 0? 2 choose 0. It will be, can anyone tell me what does it become? 2 choose 0. 2 choose 0. Yeah, it's become 1. If you don't remember, I can give you the formula. In probability, we learned about it. So it will become, this is the formula for n choose k. So you can use it to find it, or whatever worked for you. Okay. Now, so that being said, this equal to 1. Okay, what is d0y over dx0 mean? It means that you take the derivative of the function y 0 time. You take the 0 derivative of the function y. What will it be equal to? Can you guess? Exactly, it will just be y. because you taking the zero derivative of y means that you didn't take the derivative. I give you zero money, I mean I didn't give you any money. I today there's no food mean that today there's zero food mean today is no food. You see what I'm saying? So if you don't take the derivative of y, it's just y because you didn't do anything. It's still y, you know? Okay? And negative a to the power of 2 is a squared. Plus 2 to 1 is what? Can you anyone tell me? I plug in calculator at 2. Okay, d1y over dx1. It mean that, yeah, it just mean that it just mean y prime. Okay? And then negative a to the power 1 is negative a. 2 choose 2 is 1. Square over dx square. And again, this is y prime prime. Okay, you guys, yeah, I'm writing and in this notation, but you have to understand it's the same thing. It's taking the derivative 2 times, or in this case, taking the derivative 1 time. So negative a to the power of 0 is 1. So what are we equal to? I'm gonna write, yeah, it's equal to a squared y plus 2 negative a dy dx plus dy square over dx square. So equal to what? This is dy square over dx square minus 2a dy over dx plus a square y. Okay, now go back to the original. What does it saying? What does this box saying in common language? It's basically say that summation k equals 0 and into k of d ky over dxk, okay, times a to the power of n minus k. It will equal to okay, let me go it. Okay, e to the power ax times d n over dxn negative x times y. Yeah, that's basically in common language. That this is what it's saying. This is common language, or I didn't, or non linear operators or derivative operator language thing. Okay, so a lot of people ask me, how you prove this, right? So another paper go over, how to prove it. Oh, shoot. I always forgot. I'm so sorry. This is negative a. Because remember, we are doing d minus a over n. Okay? It's negative a. So, how do you do this? How do you prove this, right? Okay. The train of thought to prove this is, you start with, you start with letter. You have to start with small number, small n equal 1, 2, 3, okay, and then you try to find a pattern. Is there any pattern you can find? And if you could use induction to verify. Okay, now let's explore to this thing. Let explore this. Okay, for n equal 1, you have what? You have d minus a equal e to the power ax. A plus first, guy, always plus first. D e to negative x, right? And equal 2, you have what? D minus a square equal, yeah, I'm just gonna write it. Okay, so the train of thought is that, is there any way I could go from 1 to 2 using the first, or using any characteristic. Yeah, let me write down any characteristic belongs to 1. Okay, that's the way I thought. What do I mean by that? It means that I will try to construct 2 using 1, and then later you see the pattern. I'm gonna construct 3 using 2, and then if it work, if I can find any way it work, it means that I can use induction to verify this, to prove this theorem. Okay. Okay, so let's start. Let's actually try to construct n equal 2 from n equal 1. Okay, so so I'm trying to construct this, right? D minus a square. Okay, I'm gonna write like this. Okay, okay, everything makes sense so far. All right. Now I'm gonna replace d minus a with what? With this. It's from 1, right? This is 1 characteristic. Okay, you see what I'm saying? Just gonna replace them. This from 1. From n equal 1. So yeah, if I can construct like that, I could, you know. And then what I'm gonna do is I'm gonna do this very insane. I cannot imagine I do it too, but I'm gonna go ahead and I'm gonna times e to the power negative ax there. So it would be d e to the power ax times d minus e to the power ax times a is d. Okay. You see what I'm saying? Yeah, I times them. Okay. So I'm considering this part. Let me actually write it this color so you all understand. I'm analyzing this part. I'm factoring. I'm multiply it. Okay. All right. What does it mean? What does this term means? Okay, I give you a tips. If you cannot find it, you can write in common language. Oh shoot. There's no D here. I'm sorry. There's no D here. I give you tips. If you cannot, you can write in common language, and then you switch back to the fancy operator derivative language. Okay, let me write in common language and see what I got. D I replace dy over dx. Okay, minus ax times a. This is correct, guys. I thought it's used to be. Thought is correct. I really do. I really do. I swear to God, I used to thought it's correct, but this is actually 8 times y. Okay, guys, never forget that you have a y right here. Remember, like in the last video, I told you like never forget the y right here. Yeah, there's a y, so you apply it. You cannot forget it. It means that a would times y. A is like a tiny machine. When it see y, it times it. You see what I'm saying? Okay. So let's go ahead and analyze it. dy over dx. Okay. Okay, and this term right here, you see what is that? It is the derivative of a to the negative x. A to the negative ax, right? Alright, you see it? Using chain rule, we have what? We have this. This has become... You agree with me? Chain rule. Or, you know, a prime b plus b prime a equal ab. Okay, chain rule. No, not chain rule, sorry. Not chain rule. Product rule. Okay, now, and what is that? Now I'm going to return it to fancy language. Do you agree with me? Is this? Right? And then if you times this and this together, you get e to the power ax times d squared e to the power ax. Okay, exactly. So we successfully construct d minus a power of 2, only use characteristic we know before, or from 1, or from 1. Okay, so we can construct d minus 2 without using any further information. You see what I'm saying? So in this case, I just use like chain products rule. I use the characteristic from 1, and I use like, you know, I just times them. So basically I didn't use something new. It means that it worked. So basically you can construct d minus 3 from d minus 2. You see what I'm saying? D minus a 4 from d minus a 5. Okay, so let's do the same thing. If let's say let's construct d minus a n from d minus a to power n minus 1. Okay, so the process is very simple. Okay, so if it's correct, it means that the statement is true. You only prove it. You prove it successfully using induction. Okay, so this d minus a to power n, it will equal to d minus a to power of n minus 1 times d minus a. Okay, I'm allowed to use characteristic from n minus 1 to below. So what I'm going to use, this thing right here, again, classic, right? I'm going to replace with e to power ax d n minus 1 times ax, right? d minus a. Right? You agree with me? I'm going to replace this with this. Okay? And then I'm going to factor this in like the good old days. d n minus 1 times d e minus ax minus ax. Okay? Don't forget you have a y here. Don't forget you have a y here. Okay? Okay, and then on this thing right here in blue is the partial derivative. It's the product rule, right? It's the derivative of what? You agree? It's the derivative of e power ax y prime, right? You agree? I only show it. It's the same way you did it with 1 to 2. Okay, now I'm doing n minus 1 to n. It's the same way. So yeah, let's write it. This is d ax, right? And then you times this together. D to the power of n minus 1 times d is dn. Exactly. Oh, it's negative. Yes. So ladies and gentlemen, we successfully derive this to this. It means that from now we can use the very, very powerful d minus a to the power of n. And n is any, it can be 0, 1, 2. Yeah, n is a positive integer. We can use this very powerful, you know, operators to see what we can do. We can use it. You guys see in future video. But thank you so much for your attention. I'm sorry some of the point might be confusing, but I really do hope you enjoy it. And you know, check out the paper. I'm gonna link it. I'm gonna link it in the first video, the introduction, intro, the part one video, intro to derivative operators. And yeah, you can read for, explore. There's a lot of things, good things waiting for y'all. Okay, you have a good day.